So today's video about IoT mobile reversing is a lot less about mobile reversing than you might think, just simply because when we think about IoT and the ecosystem, the mobile app is a feature of many of these IoT devices, and what the IoT's app contains inside of it, the way certain code works, API calls being made, secrets, or other kind of information, you really just want to have access to that in a way that is reasonably parsable and something that you can dive into a little bit more. So if you're looking at some functionality, let's say in the firmware, that's very confusing and opaque, maybe there's a hint in the mobile application about what that firmware is doing at that moment. So let's dive in and see if we can put all of you, if you've never looked at a mobile app before, on the path to, having this door opened for you and then seeing what you're able to find. Mobile applications for consumer are almost entirely expected. You generally won't buy many consumer IoT devices that don't have some sort of companion mobile app with them. So practically speaking, if you buy a Philips Hue bulb, the light bulb itself can maybe change colors, change brightness, be turned on and off. And while there are definitely physical accessories that you can buy, most people generically, when they set these things up, are using a mobile app to set them up and configure them and tune them, set up profiles, etc. That's true for baby monitors. That's true for connected fans. All of these kinds of devices need some way for humans to interact with them. And really, when you think of the Internet of Things, one of the constructs I tend to lean towards is IoT isn't consumer electronics. These are not generally going to be interacted with as a direct methodology. So the line gets blurry, certainly for things like a wearable, which, depending on who you talk to, is IoT or isn't. But certainly things like your laptop that you might be watching this video on, that really doesn't fall in the scope of IoT. So a lot of the interface is really about how IoT is or is not true. And this is something that organizations struggle with to define. But I think for the purpose of when you see a device on the shelf and you go to Target and purchase it, you really got to consider, well, how do I control this thing? How do I make it do something I want? Mobile applications are often going to be the way to do so. The availability of an iOS app or an Android app is, generally speaking, for a consumer IoT device, going to be free. So you can download it, and if you're able to kind of go through some of the steps we're going to talk about today, you can look at the code and never have even bought that device. That's a really big advantage, especially for research projects, because you can look at, let's say a dozen mobile applications, and maybe you can find secrets, maybe you can find, private APIs. That can all be done without ever even purchasing the device, let alone opening the box, opening the unit, connecting to a UART. There's a lot of information stuffed in these mobile applications because they have to be kind of a gateway to the functionality of the device. Therefore, they're going to leak information about what these devices do, how they authenticate, how they encrypt, and that's very valuable information for a researcher to look into. Mobile developers, depending on who they are, in a lot of cases, a consumer electronics company might outsource a lot more of the work than you might expect. Very often, when it comes to things like mobile applications, a small IoT company could have really good hardware, manufacturing, product design, maybe even firmware teams. Mobile applications may not be kind of a first tier job responsibility. So they'll hire a development firm and they'll outsource the application creation based on their spec. These development firms may use frameworks that they use for multiple clients. They might use a lot of open source software to kind of get a head start on the development of it. So once you start looking in the mobile app, you might find interesting facts or kind of the composition and history of the mobile app. In one case, I had been reversing a connected smart toy and quickly saw some words in there that I didn't recognize, started Googling around, and it turned out the toy that was licensed by Fisher Price in this case was actually based on the same toy of a different name from a startup. And so again, you would never know these things just by purchasing a toy off the shelf. So being able to uncover the kind of the provenance of how these mobile apps are created can actually open new pathways to understanding. These developers often don't understand security research. So they might hide an API key and think no one can pull this out of a binary, or they might use an API that's private to them, not documented publicly, thinking that no one can see that traffic because they use TLS. So there's a lot of maybe false assumptions and kind of weaknesses in methodology because that a lot of developers see their code as a black box. And of course, our job as researchers or professionals in security is really to uncover what's in the black box and extract those secrets and see what we can do. The last thing I'll say here is just that there's often easy ways and hard ways to do anything, especially in security research. Today's presentation is a lot about doing it the easy way. Now, easy isn't always more powerful or more detailed or maybe in a way that you are most comfortable. But for the purposes of today's presentation, it's really about if you have a desire to do this, but you have no clue what to do to start, this is a very easy way to start. When we think of iOS, Apple, their ecosystem, I think always historically has always encrypted the actual binaries that are being shipped from the App Store. Now, your mobile device is able to decrypt these, of course, because you have to decrypt code before you can run it. And the way that researchers get around this problem is being able to load that binary into memory. The memory is unencrypted from the point of a privileged attacker that has a jailbroken device. So you literally load up this binary in the phone and then you dump the contents effectively of the memory. It's a little more nuanced than that, but that's kind of the rough cut. That is hard if you do not have a jailbroken iOS device. Jailbreaking iOS devices is harder than ever because of Apple's security model. If you have an older device and maybe it's been pre-jailbroken and an old version of iOS, you probably have an easier time. A lot of people are going to have a barrier to entry here and may stop at that point, but don't worry, that's not your only route. And when you see an iOS app in the App Store, there's a way better than zero chance that you're going to find an Android app. Now, they're different languages, unless there was like a middleware kind of a just-in-time compiler involved, but you're really looking at not the code itself, you're looking at the functionality, right? So I recommend whenever there is an Android app and you don't have some specific need to look at the iOS app, get the Android app first, look at that because it is not encrypted, and we'll talk more about how to extract usefulness out of that, but it's not encrypted. You may not have, of course, a one-to-one functionality of what iOS has, but in terms of a general purpose consumer-facing mobile app, you probably are going to learn a lot about that app just by looking at the Android app. And if you need more visibility or insight, you might then decide, okay, it's worth the time to go through this kind of multi-phase process to decrypt the iOS app. Then you're looking at binary, then you either have to, decompile this thing or really painstakingly work through all of this, this binary directly. So start with Android. It's the path of least resistance. It's the easiest way forward. Looking at Java is very readable for most people that have any kind of computer science background. So start there, and if you need to escalate, go for it. So how do you do that? One question people often have is, well, where do I get this file from? I don't have an Android phone, or I can't find a link on the Android store to do it. I recommend going to apkpure.com. I've been using this site for probably 4 to 5 years. I won't say I trust them as much as anyone randomly providing me downloads on the internet. But what I would say, they've been around a very long time. They kind of have a general purpose business model with a couple different ways they do like advertising and things. So they're as legitimate as any random place you're going to download an APK. But again, a lot of this work is going to be in a sandbox or a VM or not executing code, but rather looking at the code as a text editor, right? So pretty low risk, but I recommend apkpure.com. Just search for your app name, find the link, hit download, and then you get your APK downloaded. Very simple. Step 2 here is there's a tool called Dex to Jar. So Dex code you'll hear about Dex, you'll hear about Smalley, you'll hear about Java. Android is a very kind of weird ecosystem, Java virtual machine. It's something that again you can study up on and learn about, but suffice to say, what you really want to do is convert this DEX code into jar, and so jar is a Java archive. And so once you do this conversion, it's taking this DEX code, creating effectively readable Java from that the best it can, and then you can then inspect this Java. When dex to jar runs, it's very much just run the command line tool against the APK file, you get your jar out. Kind of buyer beware on this. You will have files that do not appropriately decompile into good Java. You might have files that are completely empty. You may have difficulties understanding some of the functional logic, or things are broken. That's kind of the name of the game here. It's not perfect. It's better than nothing, and quite often you will get a lot of valuable information and source code to look at. But just don't rely on this as kind of a panacea. You might have to, again, look at the iOS binary or do other reverse engineering or take other kind of tacks at the same problem set. There's also a tool called Jeb, so J-E-B. Jeb is commercial. There's a free trial. It's very powerful. If you want to do really anything with it, you're going to have to get a license, which I think is at least hundreds of dollars, if not into the thousands. If you had a serious project for work, or you had a security consultancy, or you did a lot of this for your kind of day-to-day research, Jeb is a great investment to make. For the rest of us that just want to do this stuff once in a while and learn a little bit about the code, dex to jar is probably good enough to get at least started. Once you've got the jar file, you really can open the jar in anything that understands Java, Java archives, and you can pull out the Java files from the archive and look at things directly in Vim. You can use strings. JD GUI though, so that's JD GUI GUI. Free application, very simple. You can open a Java archive. It breaks up the structure pretty reasonably, gives you drop downs, gives you basic search functionality. I use it quite often. Certainly better ways to handle Java code than this, but it is free. It's very lightweight. So if you're looking for just something to look at and have kind of an interface to search within, this is as good as anything kind of random that you might find. So give it a try if you're not used to doing things in Java. Otherwise, I'm sure you have better ideas. So you open this up, you look at the kind of file structure of these class files and the hierarchy. You will probably look for things like controllers or modules or functionality that's not very superficial. So kind of ignore the UI elements, the UX elements, the data models. You can ignore a lot of inclusions, like it might have Google Analytics, or might have some sort of like Crashalytics for crash handling and reporting. Generally, that code is just going to be a module they've included as a third party's module. What you really want to look at is for the code that actually builds the app, that provides functionality from the developers of the application. When you're looking at these mobile applications, it's hard to say what you might want to look for, just because based on the context of what the app does, there's a lot of variability. A few ideas I threw out here, just cryptographic keys. So sometimes you might have some sort of certificate that's used in authentication, which could be very interesting. You might find other things, like a mutual TLS or something like that. You might also find a private key accidentally included that might have, like, let's say, signed firmware. Developers have definitely been known to accidentally leave artifacts like that in. Secondarily, things that you are more likely to see, I would say, are API keys and tokens. So AWS access credentials, there's a bunch of prefixes for these, but AKIA is a very common prefix. And you might just see strings that say like AWS token or AWS key. So, kind of use some guesses like, authorization or access or token, and you might surprise yourself in the sorts of things that you can kind of extract. Be careful when you're searching to do case insensitive searching, because you might be searching for token with a capital T and the string's actually lowercase t. those are the very simple things where you think you're doing a good job searching and then you make an accident like that, and all of a sudden you're missing out on good content. APIs, if you don't know how an API works for the device, because maybe you don't have the firmware or you're not able to do man-in-the-middle network traffic, look in the mobile app, and often you're going to see string builders or encoders. These are going to build the actual API calls. And so you might have one method called like get login, and there might be a string that's slash login, and then some data gets passed to that, and then there's a header added. So you kind of have to maybe sometimes piece these together. It might not be as obvious as one giant string. But again, look for things like V1, V2. Those are often going to be the prefixes in a URI for version APIs. You should also just look for things that have forward slashes in them. You might get a lot of kind of noise, but a forward slash string in certain class files, like a URL builder one or something like that, you might get lucky and start finding these URIs, and very often you will find ones that were never meant to be exposed. The other part of APIs, or just really kind of services in general, start looking for host names, .coms and .nets. Start looking for IP address prefixes or IP address kind of notation. You will very often find hidden services that run this device from the back end that are never published. And this is the great way to really find out about third-party service providers that your vendor didn't tell you they use, and your data might be going to them, your passwords might be going to them, and really kind of take an extra look for host names and IP addresses and other hard-coded values in these mobile apps. Firmware updates, while there's a lot of modalities to do firmware updates, one thing I've seen more often than you might expect is the mobile app is actually the first part of a firmware upgrade on a device. So the mobile app might get a notification that says, hey, there's a new firmware version. You click a button, your mobile app talks to your device, and then maybe even sends the actual update file to the device from the mobile app. I've literally seen that in multiple devices. So look for the words like firmware or binary or bin. Look for things like upgrade methods or update methods. Again, this is all a crapshoot until you kind of dive in, but you might be surprised how much information about firmware you actually find in a mobile app. And then lastly, but certainly not least, passwords. So key, secret, digest. You might see a base 64 encoded authorization header. These are the kinds of things that, again, developers don't think that you can see, or it's kind of in the background and they just don't expect you to ever have access to that. I've seen obfuscation here as well, where people will do kind of crazy routines to build a passphrase and then pass it in. Most of those are very easy to sort out by just copying and pasting the Java, compiling it, running it, and then getting whatever the answer is out of it. So there's certainly a lot of ways to fix a way that a developer tries to be a little bit clever. You know, two strings from this test app that I just downloaded from an old device I used to look at. You know, you find API key literally, you find secret string literally. Now, if these are bad or good or damning, you know, that's really more of the next phase of reverse engineering to understand what those strings do, how they're used. But certainly just finding those in code in the first place is a really interesting thing and kind of leads you down different, hopefully not rabbit holes, but hopefully avenues with which you might learn and uncover more. When you look at a mobile app, the code, the reverse engineering is definitely a part of the equation. But if you can intercept the network traffic, it's often the quickest way to learn, again, about API calls, passphrases being sent somewhere, other information that is just much simpler to look at dynamically than it is trying to piecemeal it together in static code that's partially broken. So iOS specifically, since I'm an iOS user, I have a little bit more insight here. iOS specifically, they started doing this app transport security or ATS. And I think it started with iOS 9, but it's gotten increasingly more strict. From my own experiences with iOS 12 on my iPhone X, you cannot do things that you used to be able to do. So I used to use technology called MIDM proxy. You'd install kind of this leaf certificate on your device, you'd trust it, and then you could intercept anything that didn't have like explicit SSL pinning. That doesn't work like that anymore in my experiences, and there might be a range of reasons for that collectively, but one thing I have found is Charles Proxy, which has been a Mac proxy for a very long time. They actually have a native iOS Charles Proxy now, and I think it's like $8 or $9. But the great thing about this is Charles Proxy installs a root CA certificate. You have to go through a bunch of steps to approve it because obviously you don't want to be able to do that easily. And that process will basically obviate all of this other kind of security, transport security methodology Apple's put into place. And then you can select which specific host names that you're getting traffic for that you actually want to allow that kind of man-in-the-middle decryption of TLS. Again, if the app developer is explicitly pinning TLS, you are not going to be able to work around that just because Charles Proxy is installed. That's at the app level, not at the kind of OS level at that point. However, if you do go to the trouble of jailbroking a phone, there are things like SSL kill switch. I think Burp Suite has a kind of secondary markets, the Cydia kind of app store. I think they have functionality they can do, but there are ways on iOS to bypass cert pinning. All of this said, if you do have an Android device that you're able to work with, taking away cert pinning through an Android app and kind of like recompiling the Smalley code that you can interact with, you can often get past pinning in Android easier than you're going to be able to do it in iOS. So again, it's kind of your ecosystem, what hardware you have available, what kind of access you have to things like jailbroken devices or rooted devices. But for a lot of people, if you do have an iOS device, buy a copy of Charles Proxy. You can do all the recording on your phone, and then you can actually share the resulting file to your desktop so that you can then inspect it on your desktop in an easier interface. But the network traffic of mobile applications for IoT is one of the biggest and easiest ways to learn about an IoT device. So I highly recommend you put some time into figuring out what the right way to do this for your research setup is. A couple other things to know about IoT, really, I guess mobile reversing more generically is number one, there are plenty of ways to obfuscate code. So obfuscation can range from very minimal to like, as in like removing variable names, removing function names, replacing it with kind of nonsense, all the way up to commercial level technologies like ArcSAN or Whitecription that do a wildly successful job of obfuscating code such that the amount of time it would take you to manually reverse engineer is really not even a consideration. And many of these platforms are very dynamic. So it's a very hard challenge for a reverse engineer without a very dedicated target without a lot of time to actually bypass kind of the obfuscation in a commercial technology. Now there are things like DexGuard that are good from the perspective of doing nothing as a mobile application engineer, but often you can kind of work around it as a reverse engineer. So keep an eye out, but I would, really caution diving too far down the rabbit hole. If you see obfuscated code, you can spend a lot of time, make very little progress. There are two great tips though that I would share with you. Number one is a lot of times mobile application vendors will actually encrypt the application after a version has already come out, obfuscated, after a version of the app has come out that was not obfuscated. So the app developer is assuming you will only see the newest, latest, and greatest apps. So if you go through app archives, which you can find online many places, and there's other ways to kind of get archival copies of different versions of an app, if you can find one that is not obfuscated, as long as they used a similar code base or maybe the same APIs or maybe similar methodology, even if some of the code did change, you still might have a head start that you wouldn't have otherwise with the obfuscated code. Another thing is, commercial things like ArcSAN make you pay per platform. So it's possible the developers decided, hey, let's, pay for, $100,000 for obfuscation of our Android app with ArcSAN, but because iOS is encrypted and it's a binary, let's not pay another $100,000 to encrypt that platform as well. This is very serious money. So if some developers think they're being clever, by only encrypting Android because it's easier to read and decompile, etc. You might get lucky if you then look at the binary for iOS. Between these two tips, you're going to hit pay dirt most of the time. So give it a try. Don't get frustrated if the first thing you look at is obfuscated. The next thing to think about is in terms of dynamic testing, if you can interact with the mobile application is going to record maybe secrets to the keychain. They might write files to the file system. Those are, again, hard things to maybe see static code analysis wise, but by looking at the file system after the app is run, these are very easy to see. You could use Android or iOS simulation to do this. I would say, again, Android's a little bit easier overall to get to that goal. However, the best way, again, if you have the hardware, if it's jailbroken or rooted, doing real hardware is very fast. The simulation, emulation can be very slow, even on good computers. So again, another investment, another overhead thing, but there's cascading value if you do have kind of a dedicated research device. It will make a lot of things go fast. And finding some of those secrets or configurations on the file system, again, unlock a whole new window of possible information you didn't know about or couldn't know about if you hadn't looked. And then kind of wrapping up is in this broader spectrum of mobile reversing for the purpose of learning about this IoT device or finding new attack surface is one thing. There are tools. In this screenshot, I'm calling out MobSF, which is an open source free project on GitHub. It's been in development for a very long time, and it provides both static and dynamic kind of interfaces for doing mobile security assessment. So while I don't necessarily care if a intent filter in an Android app exists, for instance, because I'm not actually caring about protecting the mobile app, I'm caring about finding secrets in the mobile app. MobSF has, again, functionality that you might not need for this work, but if you want to do a little bit more in Android security or iOS security, a tool like MobSF can help. If you are just doing the reverse engineering thing for IoT to learn more about it, some of the functionality in the static code analysis way, and also the dynamic way, frankly, you might shortcut some of the overhead or some of the manual searching, and it could just simplify a few steps. So again, that's another tool. If you start Googling around for mobile application reverse engineering, there's the Android Hackers Handbook, the iOS Hackers Handbook. Mobile security as a topic is a huge world unto itself. And so I think practically speaking, if the goal of your research is to hack an IoT device or learn about an IoT device, don't get too sucked into mobile application security. Think again about the mobile app as just a conduit to learn more about your target, which is the IoT device, the IoT ecosystem. But at the very least, hopefully today's presentation, if you've never done this before, this is kind of the quick start, quick and dirty for sure way of getting started here and being enabled to do something like this that you've maybe never done before. So feel free, again, hit me up on Slack if you have questions, on the discussion board or email. I'm glad to try to take a look at an app with you, briefly, or try to give you some hints on where I might look. But really just getting started, go through all the code you can, start coming up with some good search strings, and you might get lucky. So good luck. We'll have another video in a couple weeks here on a completely different topic, but hoping these are helpful for everyone. And again, looking forward to seeing everyone's success this semester.